I'm going to start with the silicon 60-watt charger that he showed over there, and let's compare it to even some GaN discretes. This is a competitor GaN product, which is a nice size reduction. This one happens to use a D-mode GaN IC, as we talked about before, and here's the inside makings of that. And I wanted to contrast even these. While it is a nice shrink compared to silicon, you can see a lot of passives. So the GaN chip is on the opposite side, but the real action is on the top of the board, because that's where all these passives are, and they're the real problem. Still a really large transformer right here, a bunch of EMI filters to handle the high frequency noise, and a lot of large capacitors. This thing is still running. Although using GaN, it gets a nice little bump in efficiency, a nice size reduction, still running about 100 kilohertz. This is a GaN IC. This is the inside of that OPPO cookie charger. This thing is running in the 400, 500, 600 kilohertz range using a GaN IC. Again, the GaN IC is on the back, but the action is really in all those passive components, and these are similar power outputs. All those passive components, that transformer here is shrinking into that thin, simple little core. All of these capacitors are disappearing into small ceramic capacitors scattered throughout. The EMI filters that you can see here, you can barely even see inside this cookie charger. Again, this is another great example. Speed and efficiency is the key. GaN ICs unlock that speed and efficiency. We didn't put much of a spotlight on it, but I want to emphasize further, traditional AC to DC power supplies are designed at low frequency using very large, what we call wire wound or bobbin toroidal transformers. This is what's shown here. It's a magnetic core on the inside, but to create the transformer, you have to wrap copper wires around it. Often a manual process, or automated is very difficult. You can see big, bulky, ugly, expensive, wire, hand-mounted in manufacturing, not conducive to automated manufacturing. Once you get north of 200 kilohertz, you can enable these planar transformers. The core is flattened out and miniaturized, but more importantly, the wires that were wrapped are now printed. They're so tiny at high frequency, they're printed inside the PCB, making it possible to use completely surface mount automated production equipment. This turns into this. This is the future of power supplies. This is why they're so big and bulky today. On top of the fact you have large EMI filters and large capacitors, all of these things miniaturize into planar magnetics or PCB magnetics like this. This is true at 20 watts. It's true at 20,000 watts, like we're going to look at in a few minutes. Speed and efficiency is the key to power density. GaN ICs eliminates that delay and parasitics to make that speed and efficiency the maximum possible achievable. Simplicity and reliability is a secondary big benefit of GaN ICs. We showed you in the PowerPoint these two cards. These are the actual daughter cards of a GaN E-mode discrete. You can see the dozens of extra components needed to produce it compared to the GaN IC. Simple, half the footprint or a third of the footprint, half of the components. But more important than the footprint and simplicity is its perfectly well-controlled waveforms. And they're well-controlled because they're all inside the GaN IC. The customer cannot affect them. The customer cannot make a mistake. Even doing the best job we could, or any customer could, you're prone to erratic, unpredictable behavior, overstress, glitching, other things that can lead to reliability and poor performance and increased loss. We have a beautiful 6-inch GaN wafer. Again, very advanced material. Navitas had very advanced design, but we can build all of these in low-cost, commonly available silicon manufacturing tools in terms of the wafer fab, in terms of assembly and test. It's really the epi growth that's unique to GaN, and for that there are off-the-shelf epi reactors available from multiple suppliers, as GaN described. And then finally, we're going to be going from low power to high power. So an example of a transition of that, this is the world's, well, this is if you're a gamer. I don't think we have any in the room, but if we do, speak up. This is what you might deal with for a powerful gaming laptop. 300-watt adapter with silicon. Who wants to carry this around? It's heavier than the laptop it's probably charging. We worked closely with NVIDIA and ASUS to create the world's most powerful, smallest and lightest weight gaming laptop adapter, 300 watts, the same power as this, about 4 to 5 times smaller and lighter weight, and that is in production today.